Welcome to Light Over Heat with Professor David Yamani. Today I have the third of a 5-video series on what I'm calling the standard model of the irrationality of defensive gun ownership. And today I want to talk in particular about how guns add risk for negative outcomes. So let me begin by reviewing where we're at in this standard model. So the standard model begins by recognizing the existence of gun culture 2.0. Check. It discounts the need for or utility of guns for self-defense. I covered that in last week's video. Look for the link in the show notes for that. And so today we see that the standard model holds that the exact opposite is true. Instead of making us safer, ownership of firearms for defensive purposes actually makes us more at risk. And as we'll get to by the end, therefore, defensive gun ownership is irrational. It doesn't lower our risk, rather it does the exact opposite, increasing our risk of negative outcomes. Now, as many of you know, seeing guns as a risk factor for negative outcomes is really central to the public health approach to firearms. And this tradition of scholarship is really decades old. So we can go back to one of the founding publications by Arthur Kellerman and his colleague in the New England Journal of Medicine, published in 1986. And let me quote from the conclusion in that article. They say, for every case of self-protection homicide involving a firearm kept in the home, there were 1.3 accidental deaths, 4.6 criminal homicides, and 37 suicides involving firearms, and handguns were used in 70.5% of these deaths. So they conclude, the advisability of keeping firearms in the home for protection must be questioned. Now hang on to your hats, because in order to get into this public health literature on guns, we need to understand a little bit about the research methods which underlie this kind of research. Now, if we wanted to understand in the best possible way the causal influence of gun ownership on some outcome, we would want to use the gold standard, the randomized experiment. Right now, in this type of design, what we would do is we would take two people at random, assign one to the treatment group and one to the control group. In this case, the treatment group would be owning a gun, the control group would be not owning a gun. We do this over a large number of cases, and if we saw certain outcomes more commonly in the experimental group than in the control group, then we could reasonably assert that the causal factor was the treatment. Now, it is unethical and practically impossible to assign people to treatment and control groups that are based in gun ownership. So what we have when we do scholarship in this tradition are various workarounds. So for example, we could use ecological designs, right? We could look at, for example, the rate of firearms ownership in a state and the prevalence of certain negative outcomes with firearms in that state, right? And then we could compare different states with different levels of firearms ownership to see whether there's an association with those negative outcomes. And this is actually done fairly commonly. These also have some fairly commonly understood limitations, notably what we call the ecological fallacy, making causal inferences about individuals on the basis of population data. Now, an approach that gets around the ecological fallacy is what we would call a case control design. This is a quasi-experimental design because it mimics the true random experimental design, but not in a perfect way. So in this case, what we have is people who experience the outcome of interest, right? So they're either a homicide victim or a suicide victim, for example, right? And what we have to do in order to make some causal inferences in this case is to find a group of people who didn't experience that outcome, but who are otherwise the same as the people who did experience that outcome, right? So this is the control group, in quotes, or what we would call the matched sample. And in this case, we would try to find people who were exactly the same as the case sample, except that they didn't have exposure to the risk factor. So in this case, again, the same as the people who experienced the negative outcome, except that they didn't have firearms in the home, right? And using that design, you can make causal inferences between the case sample and the matched sample, assuming that the causal factor is the exposure to the firearm in the home. Now here, we again have some limitations because when we say matched sample, these people have to be pretty much exactly the same, except that they didn't have firearms in their home. And this is not as easy to do as it might seem. And so we have the problem of confounding variables, right? So we may observe a relationship between gun ownership and the negative outcome based on the case versus matched sample. But if there are confounding variables out there which are related to that negative outcome and also related to gun ownership, right, we may be seeing a spurious correlation between gun ownership and the negative outcome when the real driver is those confounding variables. Now, this doesn't discount all case control designs altogether. Case control studies were used to establish a connection between smoking and cancer because, like gun ownership, you can't ethically or practically assign people to treatment and control groups randomly and say, you have to smoke, you don't smoke, right? And so case control designs are very useful, but we have to acknowledge the limitations in them. Now, an even better design in terms of establishing the causal influence of a particular risk factor is what we call cohort studies. So in a cohort study, we're going to begin with some study population, and then that study population is going to self-select itself into different groups. An exposed group, right? This is analogous to the treatment group, and a non-exposed group. This is analogous to the control group. And then we can see whether the prevalence of the negative outcome of interest is more common in the exposed or the treatment group versus the non-exposed or the control group, right? Now, already there's, a bit of a cautionary note in that the exposure, right, whether you go into the treatment group or the control group, the exposed group or the non-exposed group, is self-selected, right? So if there's something systematically different between the people who go into the exposed group and the non-exposed group, then that's going to be a confounding factor, right? But beginning with a population and then breaking them into exposed and non-exposed groups is better than the sort of case control design where you're really trying to match people up. It more mimics, again, that gold standard of the true randomized experimental design. Now, one reason that these cohort designs are used less commonly is because they're a lot harder to accomplish, but we do have a few examples. I'm going to talk about a recently published study called Homicide Deaths Among Adult Cohabitants of Handgun Owners in California, 2004 to 2016, a cohort study by David Studdert and several colleagues. And I picked this in particular because it's a study that my students in sociology of guns this semester and I have recently read, and I think it's a good example of some of the insights we can gain from cohort studies, but also we want to talk about the limitations as well. Okay, so the basic methods of this is that we're looking at over 17 million adults in California who at the start of the observation period did not own a gun or did not live with a person who owned a gun. Of those 17 million, a certain number will move into the exposed group by moving in with someone who owns a gun, or someone with a gun moves in with them, or someone they're cohabiting with acquires a gun, right? So they are now in the exposed group, and of those 17 million adults in this study, about 3.4% were exposed to guns as a risk factor during the period of observation, right? Also, in the period of observation, about 1,495 of the 17 plus million people were victims of firearm homicide. So 0.0085% of the total sample were victims of homicide. So the question this study investigates then is, were those who were exposed to firearms through cohabitation more likely to die of firearm homicide than those who were not exposed, right? And one of the hooks of this study is it's for them akin to secondhand smoking, right? So you don't smoke yourself, but you may increase your risk of cancer by cohabiting with someone who does. In the same way, you may not own firearms yourself, but you may expose yourself to greater risk of homicide or suicide or some other negative outcome by cohabiting. It's a secondhand risk of gun ownership. And the answer that Studdard and his colleagues give to this question of, were the exposed people more likely? They say the answer is yes. And they say that you are 1.5 times more likely to die of firearms homicide if you cohabit with someone who owns a firearm than if you don't. You can see this in their figure 4, which is the adjusted cumulative incidence function for homicide by firearm among cohort members who did and did not reside with handgun owners. So you can see from this figure, over time, everyone is more likely to be a homicide victim because that's how life works. But if you were not exposed, you had a 0.008% chance of being a homicide victim. And if you were exposed, you had a 0.012% chance of being a homicide victim. So based on this finding, and there's more in this paper, I'm just trying to pick out the highlight. Based on this finding, the authors conclude, if firearms ownership enhanced personal safety, as many gun owners reportedly believe, tolerating some elevated risk might be considered a worthwhile trade-off. This study adds to mounting evidence that no such trade-off exists because a gun in the home is associated with higher, not lower, risk for assault. People who do not own handguns but live with others who do bear some of that risk, and the amount they bear appears to be substantial. So again, here, a very clear example of the irrationality of gun ownership, right? Discounting the need for or utility of guns for defense, holding that the opposite is true, that guns add risk, and therefore defensive gun ownership is irrational. I'm sorry to interrupt this video, but I'm editing it today and I realize it's just gone on way too long. I haven't even gotten to my critiques and I'm already longer than a typical video. So what I'm going to do is I'm going to post this video up to this point, and then next week I will post a second video in which I critique this particular study as well as offer my broader perspectives on the public health scholarship on guns as risk factors. Thanks for your attention. Any questions or comments you have, please leave them, and I will try to get to as many of them as I can.